So we're at BobCAD.CAM, and we're going to be starting the webinar today with our article that we have created for each live event. You can see the one before it is the NC editor, your new best friend in G-code, as it's written here. The webinar before that was the SolidWorks CAD. So if you're more of a reader, you can go to the article here and read about the webinar. If you're more of a hands-on learner, you can view the video and follow along, because I'll be using one of the demo files to follow along today. And with this, we have, so at the very top, we've got tips to optimize your programming workflow. There's 6, 7, 8 different topics that we have in this article. We'll be going over all of them. I've got sort of a list of my own things to go over as well to optimize our computing time and machining time here, optimizing our toolpaths. First, we're going to be starting with a solid setup. So with a solid model, setting up the workpiece, stock wizard, machine setup, and all of those pages until we get to our CAM tree to create some milling operations. Then don't program blind. We can set up different toolpaths, different colors for the toolpaths, so we can associate between the different ones, show or hide the toolpath at any time, things like that. We're going to be going over adaptive toolpaths, so how to create and understand the rest roughing options, rest roughing and rest finishing. You may have heard that as rest machining before as well. What that's all about, we'll be taking a look at our adaptive toolpaths with adaptive roughing, and also take a look at our adaptive feed rates as well. Some new options in the newer software versions of BobCAD. Next step, let the software handle the details. So we're going over rest finishing, going over setting up an operation stock, setting up a boundary, top of job, bottom of job, to set limits in X, Y, and Z for our toolpath. Same with trimming the toolpath up that way, boundary, top of job, bottom of job, and then also setting up our tool list. We can set up a tool crib and a tool library and differentiate between the two, what's good with setting up all of your tools in the tool library, setting up a short list of tools in your tool crib that you're frequently using, and just other ways to optimize the toolpath here. So we'll take a look at the software program here. Okay, so next we've got the toolpath. So we're going to be able to see some of the toolpath options. It's really hard to see all of the, or hard to see the 3D model with all of the toolpath in the way. So what I can do is over here in the CAM tree, there's this icon for blank and unblank toolpath to show or hide the toolpath, with this icon with an eyeball and slash through it to blink it out or to show. The icon next to it is to post. So this post yes, no option has the icon of a controller with a red X, which if I simulate or post the G-code, it will simulate the drilling operations down here, but not the 3-axis toolpath with this icon showing next to it. So let's say we've done all of the 3-axis milling operations and I need to drill the holes. I can turn off this feature and then post the G-code so I don't have to delete it and then recreate it if I need to. You can just turn it off temporarily. Next, sure. Okay, cool. Got you now. Okay, so next we can next. So blank, unblank, post yes, no. We've got highlight toolpath. A lot of customers don't see this a lot, or don't know that this is available. It's actually pretty helpful. You can see all of the toolpath in here. It's hard to see. So if I drop down a feature and I click on one of the operations, it will highlight just that toolpath for me. So I've got 2 advanced roughs in here. I don't know which one advanced rough is, and then advanced rough 1 is the next one. You can see it's highlighted, so I can easily find it right in the corner there. I could also individually blink out the toolpath in here. What I normally do actually is I blink out all of the toolpath and then I click on one of the operations for it to show, so I don't have to show and hide with a blank unblank option. I just click on each one to highlight it very quickly and easily there. And the other option, other than highlighting toolpath, we can also change the toolpath color to differentiate from it by just right-clicking on the pencil mill operation here and going to color and changing the color here from purple. Let's do a yellow color. And so you can see the yellow color very bright there for my pencil mill toolpath to differentiate it from the other toolpaths in there. And sort of on topic with this would be calculating the toolpath individually. So let's say I only needed to recalculate the pencil mill toolpath. When I go into the feature, you can see I've got 5 different 3-axis milling operations in here. And I don't want to have to hit compute here in the feature to compute all 5 toolpaths all over again. That'll take a few minutes to compute all of them. So to save you some time, instead of hitting compute, and also instead of hitting cancel will not save the changes that you make in here for the pencil mill. But if you hit finish, let's say I change the machining tolerance, I don't need it to 1/2 thou, I can change it to 1 thou. Instead of computing all of the milling operations all over again, I hit finish, which will save the changes, but doesn't compute the toolpath. So then I can go to the CAM tree, right-click on the pencil mill individually, and hit compute toolpath for just the pencil mill individually there. So you can see it only took 5 seconds rather than 5 minutes to calculate all of the other milling operations all over again when I haven't made any changes to them. Let's see what's next. We have the adaptive toolpaths options. Let's go to the feature 3-axis again. And basically how we create this in the Mill 3-axis Pro was by going to Machine Setup 1, we go to Mill 3-axis, we select our geometry by just selecting the solid model, and it's going to rough out everything in here. It's not going to, we actually have an option to avoid holes, so we don't have to create a boundary. And a big reason why I don't have a boundary on this one is because we can go past this surface edge, and you can see the toolpath out here. It's going to start down here off of the stock and work its way in with the side of the tool. So that's going to save us life of the tool, I would say, rather than plunging down in with the tool. We're using the end mill, the end of it, so we're starting from the side of the stock, working our way in. Then we have our machining strategy options. Our first 6 operations in the available operations here are the 3-axis standard, and then we get into the 3-axis Pro. So the first 6 are Z-level rough, Z-level finish, planar, back and forth toolpath to plane across the surfaces, spiral, radial, and plunge rough. Then we get to our 3-axis Pro milling operations. To be quite honest, I don't use the standard milling operations because everything that offers is included in the 3-axis Pro with so many more options to optimize the toolpath included additional to that. So you can see, like with the Z-level rough, we have an advanced rough. With the Z-level finish, we have an advanced Z-level finish. With the spiral, with the planar, we have an advanced planar. With the spiral, we have the equidistant toolpath to spiral around the surfaces. We also have flatlands to mill any flats, pencil to mill any fillets along the part. We also offer project curves, where we can project a 2D shape onto a 3D surface to do a 3D engraving milling operation. So we'll get back to the feature that we have preloaded in here, where we have an advanced rough. We added an advanced rough. We added a Z-level, an advanced Z-level finish, an advanced planar toolpath, and a pencil toolpath. So to add more operations, we go to our available operations on the right-hand side. Let's go to advanced planar, add that over with this arrow. I can sort the operations by highlighting one and moving it up and down in the list. And I can delete operations by highlighting one and hitting the red X button here. Then we go to our next page where we have our posting number to ask for the work offset number G54. Our user interface choice, standard user interface versus advanced UI, and it asks different options, just a different user interface, asking different step over options and things like that to optimize the toolpath as well. We could get into later. Then after we set up the tool for the roughing operation, then we get to our cut patterns. So here's where we get into the adaptive toolpaths. We have our different cut patterns here. I normally start with parallel to explain it. You're just going to zig or zigzag back and forth inside of the pocket and step over each time. Offset out is where you're starting from the center of the pocket and you're working your way to the side walls, where offset in would be starting from the side walls and stepping over to the center. So those are our standard toolpath cut patterns for roughing. Then we get into our high-speed machining options with morph spiral and adaptive roughing. So morph spiral is going to start at the center, continually spiral its way out, keeping constant tool engagement until it gets to the side walls. And adaptive roughing, which is our trichoidal milling, which it starts from the center and spirals its way out as well. When it does a zig pattern, just one directional cutting, when it gets to the side wall here, and to get to our next location over here, the tool is going to retract a fraction of an inch and wrap it across, come down, and then get to our next location there. So that's our trichoidal milling. The reason why these two operations are high-speed machining and take less time to machine them than the offset options is because the offset options are stepping over every time, and that's wasted time where it's not machining anything out. These yellow linking moves here, it's just going to feed across, stepping over each time, and not machining any material. With the morph spiral, it's completely engaged in the material, or I guess you could say it's engaged in the material consistently, always machining rather than stepping over and wasting time that way. So there's our cut patterns, our adaptive toolpaths there for roughing. Then we set our depth of cut and our step over amounts. We set an allowance. We're leaving 40 thou along the sidewalls and the flats to mill out later with that next advanced rough operation. Rough out the rest of it with a smaller tool. This one we've got plunge, ramp, spiral down into the material, entering into the stock. And here's the next option that we have for optimizing the toolpath, rest roughing. It can also be considered rest machining, if you've heard that term before. The rest machining is sort of a broader term. We call this one rest roughing because this is a roughing operation after a previous operation. Then we'll get into the rest finishing, which is one of the finish passes here, or one of the finish operations that will machine the rest of what we did from the previous roughing operation. So since this is another roughing operation, this is called rest roughing, I can check the box here and tell the software the previous tool that I used. So right now, in the first advanced rough, we're using a 3/4 inch flat end mill. If I used a larger tool than this, let's say I used a 1-inch cutter, I can tell the software the previous tool diameter and the corner radius that I used. The software will calculate any areas the previous tool couldn't fit into and calculate just that toolpath for us. So essentially, it's going to start right where we left off from the previous operation and avoid any error cutting. So again, that's going to save us a lot of time, eliminating all of the air cutting moves there with the rest roughing. Linking for each step over, our gauge check page, our advanced feed rates. This will be the next one under adaptive here, where we have adaptive feed rates. First, if you haven't looked into the advanced feed rates before, the convert rapid moves to feed moves allows us to, if we're not able to set a rapid rate at the controller, we can change the rapid moves to feed moves, and we can set up that rate here in the G code itself. And we can also set the feed rate where it's linking between groups of geometry like this to speed up that process. And then here's our adaptive feed rate option. So on the tool page, I know I'm jumping back and forth, so I appreciate you guys' patience with me. You can see the cutting feed rate. We're at about, let's call it 60 inches per minute here, right? So if I type in the cutting feed rate of 60 inches per minute on the tool page, I go to my advanced feed rates, and if we have the minimum feed rate set at 10%, it will go anywhere between 10% of that number up to 100% of that number, 60 inches per minute. And when it gets into larger material at a time, like into these corners, the software can calculate how slow the tool needs to move to keep a constant chip load, and that can reduce chattering at the machine. So it's going to calculate the certain amount of material per tooth of the tool as it's getting into the material here. If it needs to get all the way down to 6 inches per minute, 10% of the feed rate that I have, it'll go anywhere between 6 inches per minute to 60 inches per minute to keep a constant chip load. And so that's going to help a lot with the life of the tool. Don't want to break any tools there. It'll also help with chattering at the machine when it gets into the corners. It'll slow down for you so that it cuts just enough material as it were to do a linear move across the rectangle here. Then we go to the next page. We have our MDI page. That stands for manual data input. So if I wanted to add any various G or M codes over here before or after the operation, I can do that here. I can click on, here's how to do it. You click on raw text, for example, and before the tool change, I can highlight that and click on command. So whether it's raw text, let's say if it's an M01, I want to add in, or an M00, or whatever G or M codes you want to add in manually, you can type that in as raw text. If you want to add it as a, if you want to add any comments, you can click on comment here, and it will add parentheses before or after the, before and after the text here. So I can type in, this is a test comment, and it will give you an open parentheses and a closed parentheses before and after this. Let me see if there's any questions so far. No questions so far. You guys are good to go. Cool. We'll go to our next page. We've got our user interface. So I'm going to get into the advanced user interface for the next advanced rough. So when I click on that advanced UI, and then before I click on open advanced parameters, you can see there's no more pages for patterns, parameters, leads, options for my second advanced rough here. It's just got the tool and it's got the MDI page. The reason for that is because all of those patterns and parameters, those options, are going to be in a separate window here. When I click on open advanced parameters, I can type in the spindle speed, the RPM here, direction of the cut, surface paths, the next tab here. This is really the biggest reason why I would use the advanced UI, is down here at the bottom right. You can type in the maximum step over or the tool diameter. If you're using a ball end mill, let me actually see if I'm using a ball end mill for the finish pass. So let me turn on the advanced UI for that one. So for advanced E-level finish, I go to advanced UI, and open the advanced parameters. Oh, it's not asking for a step over with this one. Darn. But normally with the on the surface paths page, there's a step over option and there is a cusp height option. So it asks you if you want to calculate the step over based on the, I think this is why we're setting up a depth step here. I think it'll do it under the planar, if I'm not mistaken. Yeah, perfect. So we got to the advanced planar operation in the advanced UI. We can set up the step over, or we can set up the step over based on the desired cusp height. So if there is a specific cusp height or scallop height we need to get to, a certain deviation between the stock and our workpiece, the highest peaks here, for example, need to be, let's say, 1 thou. I can type in 1 thou here, and then you can see the step over above it changes accordingly. So it calculates it based on the specific cusp height that I need. So I don't have to go into simulation anymore and take a look at the stock and the material remaining and how much material is remaining and make sure that it's cut to size. I already know that it's cut to size based on my tolerance levels of plus or minus 1 thou here when I type in the cusp height. There's some other options in here that can be useful. 2D containment is a boundary option. We have our undercuts option. If we're doing any undercuts, we have that in the 3D Axis Pro now. And we also have rest finishing. So I'm going to get into rest finishing on the standard UI. But I'll finish up the other tabs here. Tool axis control is if we had 4 or 5 axis machining, we could do that in here as well. We have a gouge check page, linking for each step over. We have a roughing page if you needed to do multiple passes. And this utility page for miscellaneous GRM codes as well. But yeah, the best thing I normally highlight with the advanced UI is the step over and cusp height here. And then we'll get into rest finishing on the next page here under the standard UI. I'm more familiar with the standard UI there. We go to one of the finish operations under the options page. You can see down at the bottom we have rest finishing. So I can check the box. You can see that it's already grayed out the previous tool diameter and the corner radius because it pulls up the tool that I used from the previous operation and understands, well, this is the previous tool that I used. Trim the tool path based on what I've already machined and eliminate any air cutting with that option. We also have this stock STL option, and we'll get into that. This is our operation stock option that we'll get into after this here, because there's another location to set the operation stock here too. Rest finishing, operation stock. Okay, so I'm going to turn off the rest finishing for now. I'm going to turn off everything except for the first advanced rough. I'm just going to rough out the first operation here of the stock. Go to the top and click on Start Simulation. I'm going to hide the machine for now. A couple things in simulation that can be useful would be the, let's see if I got, that's fine. Let's see in simulation, a couple things that can be useful. Up at the top, you can change your simulation run speed, so we'll slow it down a little bit. You can see up at the top, it says NC. That's for NC mode. It says it will take 3,300 lines of code to do this roughing operation. If I drop that down and go to length mode, it says the tool travel will be about 525 inches. If I change it to time mode, it says it will take about 6 minutes and 6 seconds to machine this out. And I normally leave it on time mode. One reason is so that I can see the estimated cycle times. Another reason is because when I go to NC mode and I run it, it gets a little choppy. And why does it get a little choppy? Because it simulates it based on the lines, the feed moves in the G code. So when it does a linear move, it just feeds right across it really quickly. In the corners, it's a little bit slower, so it's a little choppier of a simulation, in my opinion. I normally change it to time mode because it simulates based on the run speed time, and it's much smoother of an operation that way. I know I've sped it up really quickly, but if I have like a normal simulation here, turn off the toolpath, you can see the tool going at a very similar speed all the way across, so I'm not having to jump, look at the tool, jump back and forth to try to follow it. It's a lot easier to follow there. So next, hold on, let me pause this for a second. Oh, that's not it. Sorry, 1 second here. Okay, so next we've got operation stock. So we have got operation stock. We go to the top. Just make sure we're good. Okay. Good to go. Good to go. Okay. So next we've got operation stock. I can go down to the bottom right, go to cut sim, and save it. I'm going to save it in my documents. So I'm saving this stock as what I've machined so far. If I close out of simulation, I can expand the page for advanced rough, and you can see some different options down here. We've got our gouge check that I can check the surfaces of the model, make sure there's no gouging. We've got our boundary option for each operation individually. So if I wanted to contain the toolpath inside of a certain area for each individual operation, I can do that here. Drill tip position, we're not getting into that today, but we'll get into that in another 3-axis milling, is where I can select. I have to create a point at the specific depth I'm going down to. And let's say I want to start the milling operation to plunge down into a hole already drilled, like in this location right here. I can sketch a point in the CAD geometry and use that as a drill tip position. That's where the end mill can come down first and go down into that hole and then mill it out. Then our operation stock. I'm going to right click on that, go to reselect. I'm going to go to so the first option is solid model. So if I had a solid model overlapping this one with the stock that's already been machined to where I'm starting at, I could start with that. I normally just go with STL file because it's already sort of overlaid on this 3D model from my simulation. I go to STL file, I go to browse, I select the stock STL file from the documents folder, and then you can see that's highlighted here. If I revolve it around here, you can see what's highlighted in red is my operation stock that I saved. So I'm telling the software to start from this stock that I have and machine the rest of this stock from here, rather than from my original stock in the CAM tree. So that way I don't have to go into a new milling job every time, redefine my stock as an STL file. I can do it within the progress of the milling job, operation by operation. Then If I wanted to contain the toolpath even more than this, I can set up a boundary for the operation by right-clicking on the boundary, reselect. Let's say I want to contain the toolpath. Turn off the auto connection here. Delete the selection that it gave me. I want to select this edge, this edge, this edge, and this edge here. I can contain the toolpath inside of this area in an X and Y plane. So looking down from the top of it, I would contain the toolpath inside of that boundary. Now, if I want to start at a certain Z location, a certain Z depth, and end at a certain Z depth to control the toolpath in the Z axis as well, that would be in the operation itself. I edit the toolpath. I go to the parameters page of an operation, and down at the bottom there's user defined, top of job and bottom of job. So I think this is the depth in reference to the G54 work offset location. So if I don't know the exact depth I want to start at, I can click pick. I can click on a certain point. Let's say I want to start. It's not really giving me much geometry to work off of here. Let's say I want to start at the top of the stock, so I click on that point, and it should say 0. And then when I pick on another point, I'm going to make a point here. There we go. I'm going to make a point, create 2D point. I'm going to go down 1/2 inch. You can see it highlighted just below that CAD origin location. I can go to my CAM tree, go back to the feature, go to my parameters page, click pick, click the point, click OK, and is at -0.5 in reference to normally the work offset. The CAD origin location and the work offset are both at the same Z location, so that's why it's at -0.5. So then, if I were to compute it, so if I hit finish and then compute the operation, I've got the boundary contained inside of this area, machining from my operation stock, and my top of job and bottom of job, I'm just starting at the top here, and I'm ending the operation at the Z depth. So I can hit compute. You'll see the toolpath originally, how it looks here. Let me just take a look at the entry option here. Should be good. Okay, so I'm going to right-click on Advanced Rough and hit compute. And then it's going to trim all of that toolpath away. All of the toolpath on the outside is trimmed away from the boundary in X and Y. The toolpath trimmed anywhere below the 1/2 inch depth is trimmed away because of my top of job and bottom of job. And it's only doing these 4 passes on each side because I've told the software that this is my original operation stock that I'm starting with from my operation, and to start from there. And it's right here. There we go. There's our operation stock that we're starting with. And so just machine along those stair stepping from the first Advanced Rough. What else do we have? Looks like the only other 2 things I have written down here were saving the tool crib and the simulation settings. So I'm pretty much done for the day on the different topics on optimizing our tool paths in the milling software here. So if you guys have any questions, please let me know in the comments section. More than happy to answer anything that you have going on that comes up with a tool path in the milling software. Let's see, tool crib is good. The simulation, one other thing about simulation that can be really cool is going to open it in a separate window. And I can do that by going to File, going to Settings, and going to CAM. And then I can go to Simulation right here. And I can change Simulation Window from Embedded Window to Separate Window. Hit Apply and OK. And so when I go into this simulation, it'll pop out in a separate window so that I can put it on a second monitor and I'd be able to simulate in a separate window. I can even multitask by going over here in the CAM tree, modifying it, opening up the simulation, and being able to reset the simulation, and I don't have to close out and reopen the simulation every time after that. I think it's open on a different monitor here with the simulation. Oh, there we go. So it opens in a second window here. I can maximize it. So you've got a much larger simulation window than before. And again, you can drag and drop it and put it full screen on the second monitor to be able to change it from there. So I'm going to hang back for a couple minutes, and if there are any questions that you guys may have had through the webinar today on optimizing your toolpath, you can view this live event later on the webinar. After it's live, it gets put up onto the live events page, the webinars page here of BobCAD-support.com. And then on BobCAD.com, we are at our, up at the top, you can click on News, and this is where I found the articles that we have for all of our live events. So you can see up at the top, we have our tips to optimize your programming workflow to be able to read about a little bit more that we went over today. All the different topics of setting up your whole milling job, setting up adaptive toolpath options and things like that. You can read a little bit more about it here. So yeah, let me know if you guys have any other questions of what we went over today. More than happy to answer them. And again, thank you everyone for viewing the live event today. We do this every other Wednesday. So today's April 16th. Our next one is going to be on April 30th. We don't have a topic yet. That's to be determined. We send out a survey to see exactly what you guys would like to see in the next webinar. Quick question. Is there any way to start off the part on the other 3D toolpaths other than adaptive? I'm pretty sure. So like with the other ones. So here's how you can do that. And good question, Leon. So we'll start from scratch. I'm going to right-click on Machine Setup 1. I'm going to go to Mill 3 Axis and select my 3D model that I'm going to be roughing here. I'm going to use an advanced rough, or you said anything other than the adaptive, right? Other than adaptive. So I think we could do it in the finish operations as well. Leads. No, so it's going to be in the roughing, but we can do it other than adaptive. So I'll start with advanced rough. Go to the patterns page, and you can see it starting from the outside, working its way in from the outside with offset out, offset in. I believe parallel would even do it as well, than just the adaptive or morph spiral. But what you have to do is select one of the cut patterns here. We'll do offset out. And then we go to our leads page. Instead of plunge, ramp, or any of these other ramping options other than line, spiral, zigzag, you have to uncheck the box center cutting tool. So basically that checkbox, when it's turned on, will tell the software, use the center of the tool to plunge down in with this operation. If we turn it off, and I make the depth of cut a little bit larger here, and hit compute. You can see it still has the side roughing routine here with anything other than adaptive as well. Another side note to this, so to get that set up, it can be any of the cut patterns here, anything other than adaptive also. It's normally used for adaptive, but you could use the offset options and parallel and things like that. The only other setting you have to turn off would be the center cutting tool option. Now, this center cutting tool option is found in the advanced rough. So some of you guys that use the standard roughing, you won't see that option. So that's another thing that is useful in the 3-axis Pro milling operations. Instead of using the Z-level rough, you want to use the advanced rough, so that after you select a cut pattern, under the leads page, you'll have that center cutting tool option to turn off for your side roughing routine here. And the back plot starts on this side and starts from the outside of the stock and works its way in from there. Pretty sure parallel works as well, but yeah, I know for a fact adaptive roughing, morph spiral, and the offset options work. I'll test parallel just to see. Yep, even parallel works from the outside and works its way in. As long as you have that checkbox turned off under the leads page, turn off center cutting tool. You also, here's another one too about that, is if you have a boundary, just like I had with that last advanced rough. So with this one, if I set a boundary in this same area, and then I say, okay, now I've updated the boundary, recompute that toolpath, it's going to show me nothing for the toolpath. And the reason why it's showing me nothing is because BobCAD is telling me, hey, you don't have an opening to start from outside of this boundary. You know, if I try to go and offset the tool from this boundary, I'm still going to be going down into the stock and plunging down into the stock. You need to give me something to work with, some kind of open area from the original stock to work with. So if that were the case, if you need a boundary like this, you do need to tell the software an opening, and you could even go like, let's say with some wireframe, you go with extracting your edges right here. And then you offset it outside of the stock enough for the tool to be able to enter in the boundary and work its way into that area. So if I go into line parallel and make this, offset this line 1 inch at least, I might need to make it larger here. I'm going to go 2 inches just to make sure I have enough room there for the tool. And then I go to trim 2 entities so that I can extend both of these lines out. And then I'm just gonna delete this one so we know what geometry we want to select for our boundary. And so that now, when I compute the toolpath, we do have toolpath that's showing, because now the tool can start outside of the stock and work its way in with the side of the tool. Now it's physically possible for the tool to start outside of the stock with this boundary I created. So I get that sometimes with customers. They ask, why is there no toolpath at all? Because when you are trying to do the side roughing option here, you do need to have some area, something where the tool can work, somewhere where the tool can be outside of the stock and come in with the side of the tool. If it's not physically possible for that, it's not going to show any toolpath at all. All right, cool. What about Z-level? I don't like to plunge or interpolate. Yeah, I agree. Don't have to plunge or interpolate with this one. You can do that all from the side roughing options there. All right. And if you guys don't have any questions, I want to say thank you again for everybody viewing the live event today. Thank you, Leon, for being engaged with questions there. Always like to answer any questions that you guys have in the live event to help you guys while I'm doing the webinar here, while I'm doing it live. And I hope to see you in the next training session, April 30th. And it's going to be same time, 1 o'clock p.m. Eastern Time. And thank you, everybody, for viewing the live event today, and hope to see you in the next one. Have a great day.